see how many times you've checked your grade. So, all right. So, a couple people came in.
She got locked out for 2 hours though.
Cool.
Just me. Like contacted
All right. Here we are, my friends. So it says this is on page 130. This was the backside of 7.3. All right, so problem number 10. It says wildlife officials monitor the ecosystem in state parks. Okay, and they have the following snakes. We have garter, bull, hognose, and rattlesnake. And these are all percents. So this is the expected percents. And then they have the observed. Now, the hard thing with the observed is they say this. We have these numbers. Okay. So, you have one that's in percents and you have one that's an actual number. So, it becomes, I'm going to grab my calculator. That way I can do it quicker.
Nice, Austin.
All right, so we can do probably one of two things. I'm going to say, let's see, how do I want to do this? So we know that there's a total of 74 snakes. So what I'm going to do is I'm going to turn these into percents. Okay, you probably could have gone the other way. You probably could have made the expected those values, but let's do. Let's see. Is that? Oh wait. Oh, it helps when I can. So 38 divided by 74. So wait. How are we doing this? Clear. 0.6 times 74. So that means that our expected with the percents, this would be 44.4 we would expect there. If we went through this, this would be 14.8. This would be 7.4. And this would be 7.4. So I'm just turning the expected values. Being we have 74 snakes, I'm finding 60% of 74, 20% of 74, 10% of 74, 10% of 74. So they were expecting to see these snakes. We could have done these as percents if we wanted to, which it's still going to kind of work the same way, but we'll just go with the way I've done. So let's find our chi-squared value. Remember, that's going to be our observed minus our expected quantity squared all over the expected, and then we'll sum them up. So if I go, let's see, if I go 38 minus 44.4, square it, divided by 44.4. So that's going to give us 0.92. As we go down the whole thing, 7.03, 0.02, 1.56. And then that means that this value adds up to 9.53. Good deal. Oh, we forgot to do our null, and I got two involved in that. So our null hypothesis is that the percent is correct. Our alternative is the percent is not correct.
Wait, so you want us to take the percent of each of the months?
Yeah, so what I did is because we had 74 snakes, being there's 74 snakes, what I did is I took my expected values and figured out how many snakes. If there was 74 snakes we saw, that means that 44.4 were garter snakes. 20% of 74 is 14.8. 10% of 74 is 7.4, so on and so forth. So that's what. So this is what we would expect if we only had 74 snakes that we're dealing with.
So you just converted the percents in the expected category
Into yeah, because we had the 74 snakes. So if we came across collected 74 snakes, we were expecting 60%. That means that 44.4 of the snakes, and I realize you're not going to have 0.4 of a snake, should have been the garter snake, but we had observed that there was only 38, so there was just differences in that. All right, so then I need to do, so that was 10, this is 11, so this is 10 down here, this is 11, filling that out. And then number 12 would say we're going to do this, CDF, chi-squared CDF, and we're going to go 9.53. And this has got to be some sort of huge number. So 100,000, 10,000. And then our degrees of freedom is what?
How do we know if it's huge or a small number?
Do what?
How do we know if it's a huge or small number?
Because this is when you do the, let me see, let me go. Second distribute, number 8. I guess you could have went either way. You could have went really small number, but it can't be a negative value. So if you put,
Is it like that for like all the problems?
yeah, for the CDF. So we're just seeing if it's correct or not.
All right.
Okay. So what's our degrees of freedom?
Wouldn't it be 73?
Do what?
Wouldn't it be 73?
How many categories do we have? 4 minus 1. So it's 3. Yeah. There's 4 categories. So our degrees of freedom has to be 3. Okay. You're not looking at the number of snakes you're looking at, how many categories you had. If you had 20 categories, degrees of freedom would be different. So that's going to give us our p-value of 0.023. So this is now our new p-value that goes along with this. And what's our p-value? What's our kind of our go-to? Our p-value, our go-to is what? Yeah. So this is kind of our barometer to it. So is 0.023 less than 0.05? Yes. So we reject the null.
It says using a p-value of 0.1.
Oh, 0.10. Oh, so that's even worse. So if we're doing a higher p-value, so we're ignoring that. That's the go-to. Obviously, 0.1 is a bigger value than 0.023. So reject the null. Find evidence that the distribution is different than described. Evidence that it's different. Distribution is different. And that's all we do. So, chi-squared is not as tough as other things have been. I think we've definitely seen, I think the last chapter was a lot tougher. This one is a lot friendlier. So here is reality. Let's see what we do here. So what I want us to work on is page 131 and 132. Which is the 7.1 to 7.3 review. Now here's the tough thing. Wednesday, no school. Thursday, senior ditch day. Friday is very questionable about how many students are going to be here. And I'm not saying that to be mean. I'm just saying I kind of think that by you all taking, having Wednesday off because it's the testing day and then Thursday you being your senior ditch day, I really have a hard time realizing that you're going to have a weekend and then come back for one day and then go to a weekend. I'm just thinking of reality. Now, you all might shock the living daylights out of me, and I'll show up on Friday, which I welcome you. So I would say this is due either Friday or Monday. That's when this would be due. With that known, then Tuesday we would do the 7-1 to 7-3 quiz. Does that seem okay? And we're just perusing along. We have less than 5 weeks left for you all. So I think we might even get into chapter 8. And I love how we have a final exam review number 1 and a final exam number 2 and a final exam number 3. And we don't have a final exam. Pretty cool. So don't tell future classes because maybe that'll change in the future. So let's have you all work on 131, 132. If you would like, you're welcome to come take a picture of my answer key. That way you have that for your thing. So during your days off, being you all might have a 5-day weekend, I don't know, but I'm just saying, if you wanted to like really engross yourself in stuff, you come take a picture of this page top side and bottom side. So you have that. Sound good? Everyone happy?
Yeah.
All right.